Thank you everyone for joining us in our session for design automation for Fusion. We're going to talk a little bit about the service in general, as well as our new Fusion offering for it. My name is Scott Anderson. I'm a developer working on the Fusion team, and I've also been working on design automation since it was first released. So we'll go ahead and start with our standard safe harbors. It just says that these are forward-looking presentations, and what we say in them may not be 100% accurate in the future. And we will go ahead and switch over to Adam.
Hi, I'm Adam Nagy, a developer advocate at Autodesk, and I have also been supporting design automation since its beginning. So let's start with the question, what is design automation? Design Automation API allows you access to all the automation capabilities of our core desktop products. Almost anything that you can do on the desktop, now you can do at scale using our web services. So whether we are talking about tasks like batch processing design files, or extracting parameters or data, modifying parameters, or generating drawings, all these various tasks can be done through a streamlined approach, which would make your work much quicker and also more reliable. Furthermore, because these are web services, it also allows you then to use it with your existing business systems. So that would enable you to create complete workflows that should speed up your various processes, and hopefully it would also provide you with additional business capabilities. So far, we have been supporting 4 core products. These were Revit, Inventor, 3ds Max, and AutoCAD. At the very beginning, when we introduced this API, there were some confusions around this because people were thinking maybe we were providing some kind of fine-grained access to the various functions of the desktop product APIs, but that's not the case. So actually, in fact, they work pretty much the same way like it is on the desktop, where you would have to provide something called an add-in, which would contain all the code that is interacting with the product. You would have to load it into the desktop product, and then it would allow you then to automate certain tasks. On design automation, we call this add-in an app bundle, but it behaves exactly the same way. And what the Design Automation API allows you then to do is to upload this app bundle to the Design Automation server, then kick off various work processes, which would then start up the given engine, load your app bundle, and then it could start automate that specific product. So the way it works exactly is, you have some kind of app bundle, which would be automating the given product. You might start off with some source data. It could be various models or some other information that you might need. All those are sent to the Design Automation server, which will be then running your code, either generating new content or modifying existing content. And you would also every time end up with something called the work item reports, which would include information about what kind of activity you started or what kind of activity the work item was based on, input files, output files, and then some additional messages coming from the Design Automation server, and also including all the messages that your app bundle code was printing to the console. And then you can also end up with additional outputs. It could be like derivative outputs. Maybe you started off with an invented design or an invented drawing, and you want to convert it to PDF, or a Revit model you want to convert to IFC. Or you just simply modified existing models, and that's your output. So the exact steps are, first of all, you have to make your input models and input information available to Design Automation. It doesn't matter where you upload these files, whether it's Azure, Google, Dropbox. It could be also the server, which is implementing your web application, or any of the Autodesk storage services. You just have to make sure that they will be available to Design Automation. What people tend to do is, for example, take advantage of something called pre-signed URLs. in which case design automation can just simply use the URLs that you provided and then download those models directly through that without having to use additional, for example, access tokens. So you're sending all these links to design automation. And once you kicked off the process, the very first thing it will do is, of course, download the input files you need. Then it's going to run the code that is inside your app bundle. And once it's finished, it's going to upload the results to the URLs that you also provided at the very beginning when you kicked off the work item. Something to note here is that there is no connection between the various work items. So inputs and outputs are not stored by default on our servers, but actually there is a new capability which enables you to cache outputs if you want to, and then speed up processes and communication between multiple work items. So let's have a look at quickly the various endpoints, the main endpoints that we have. That would be like the work items, activities, app bundles, and engines. And I tend to group them in two parts. So there would be one part for the execution. That's the endpoint that you will definitely need to call in order to run the various work processes. But there are some setup processes as well, considering the app bundles and activities. So when you want to upload your app bundle, which contains the code that you will be using for the automation, or you want to create the activity, which is like a template for the work item that you want to run, that contains information about the inputs and output files that the work item will need, and maybe additional parameters. So for that part, the setup process, you can actually just simply take advantage of existing tools that we have. One of them is like a Visual Studio Code extension, or we also have a Visual Studio project template, which also includes an additional project which can automate these tasks. And we also have a web application called the Design Automation Tools that can help you with this process. And then we have the engines endpoint, which simply returns all the available engines, including, for example, today now, and Fusion. The main sample project that we have on the manufacturing side at the moment is this, the Inventor config demo, Autodesk.io. And it's a very dynamic sample in the sense that it should be able to work with pretty much any of your Inventor models. And just to show how dynamic it is, for example, on the left side, the dialog that you're seeing, the content of it is actually extracted from an iLogic form that your design project might have. If it doesn't have one, in that case, we would be just listing all the available user parameters in the model. And once you change the model, obviously you can click update. It's going to regenerate the model using design automation, and the viewer will be loading the latest version of your model.
I take over from here.
But we will be switching back and forth a bit, so.
Yep.
Mhm. Mhm. Yeah.
Did you not get the?
Shall I go back to the previous slide?
Okay. Okay, thank you for that overview, Adam. Now let's go into some detail about design and automation for Fusion. So what is design automation for Fusion? It's a new engine that we're offering alongside our other engines. So now we have Revit, Inventor, AutoCAD, 3ds Max, and Fusion. The API to use the new engine is going to be mostly the same, with a few differences which we will discuss. So first of all, there are some differences on how you develop your application. So similar to other engines, you are going to develop against the desktop API, but instead of using .NET, you're going to use TypeScript. If you've done any development on Fusion desktop add-ins, you may have expected that to be Python or C++. But for design automation, we've introduced TypeScript as a new API language so that we can securely sandbox your code on the cloud. And we have a Visual Studio Code extension that will help with IntelliSense and other things, which we are going to talk about more later too. Okay, the next big difference is the fact that Fusion is a cloud native application, which requires you to log in and saves your data on the cloud automatically for you. So to work with this on design automation, we are using personal access tokens. So what this means is that you will need to go to profile.autodesk.com and create a personal access token, or PAT, that is scoped for design automation for Fusion. And when you send that to us in your work item, we can use it to sign you into Fusion and you have access to your data that way. Now, as far as inputs and outputs, you can work with them the same way you do with other engines, in that you can pass URLs to files along with any auth headers needed that are on your own servers or some publicly available server, and we will download or upload them as needed. But most of the time for Fusion, you're going to want to use your data that's in Fusion Team. So for that, you can pass URNs and access them that way. And you may wonder how you can get the URNs to those files. We have a couple of ways of doing that. So in the Fusion desktop application itself, there is a text command called data.property. And when you run that, it will give you the URN to the currently open document, as shown in the screenshot there. And the other way you can get the URNs is to use our data management API, which allows you to go through your different hubs and projects and folders and files in them. And you can get the URNs that way as well. All right, and for Fusion, we have some well-known unique arguments that you can use in your activities and your work items. The first one is the personal access token, and that one is required. If you don't send that to us, then we won't be able to log you into Fusion and you will just get an error. And the next three are optional. The first of those is called task script. And this allows you to just send a short inline script to us. And this is going to be mostly for testing simple things, because there is a limit to the number of characters you can send in the payload for your work item. So for anything that's less trivial, we have the next one, which is task script URL. And that works similar to inputs and outputs, in that you can give us a URL and auth headers to the location of your script on your server, and we will go ahead and download that and execute it the same way we would as if it were passed as task script. Now, if your application is more complicated and you're using multiple files, you can also use an app bundle, just as you would with other engines. And those app bundles can be chained together. But just keep in mind that of these three options, you can only use one of them. So if you're using task script, you can't use task script URL or app bundles. And if you're using an app bundle, you can't use these task script options either. And then finally, we have this task parameters argument, which allows you to send us a JSON object with key value pairs that you can access in your scripts. And in this example, there's a file URN parameter. And in your script, you could access that through the adsk.parameters.fileURN property and get access to that value. Okay, and then finally, there are some differences in how we handle callbacks with Fusion. If you've done this with the other engines, you know that your application needs to emit a trace statement with a special format. But in Fusion's case, we've just added this onto the API object. So you can just call them as you see there with adsk.onProgress or getOnDemand file. And we think this is a little simpler and easier to use, but it's just something to keep in mind if you're used to doing it the other way. And that's pretty much the gist of the differences for the Fusion engine. So now we're going to shift gears and talk about some tools you can use. And Adam will start that off with the tools that are general to design automation.
Yeah, first of all, we have a tool called the Design Automation CLI tool, which is like a command line interface. It's very useful to automate pretty much all the various tasks that are available for design automation, including uploading an app bundle, even like signing an activity so that you would be able to use three-legged authentication, a three-legged token with it, and all the other things, also including running work items. And then we also have the Visual Studio Code extension that I briefly mentioned before on one of the slides. Apart from the design automation capabilities, it also has data management, API access, derivatives access, and webhooks access. So you can check your buckets, create new ones, access the hubs that you have that are available for you, or create webhooks in order to monitor the various events that are happening on the Autodesk platform services. And we also have a web app called the Design Automation Tools. Here as well, you can use your client ID, client secret in order to check all your app bundles or set up new ones, updating existing ones, set aliases to them, manipulate the various activities, and run even your work items. And as you can see, once you've run a work item, it also provides some details about, for example, the running time of the work item, how much time was spent on queuing, downloading the input files, then the actual running, uploading the results somewhere, and then stopping an overall time of the work item.
Okay, and now some tools that are specific to Fusion. So as mentioned, we have a desktop add-in. So when you open this add-in, it gives you this dialog here that allows you to manage your scripts. So you can delete them, create new ones, import them, etc. And when you edit them, it's going to open them in VS Code. And so when you open them in VS Code, you will be prompted to install our VS Code extension. And as we talked about earlier, this extension gives you IntelliSense, has the TypeScript definitions for you, and it also gives you the ability to run a script against a local Fusion instance for testing, as well as run them remotely on the cloud. And we will see a demo of that. So let's go ahead and get into some demos now. Our first demo is going to be around local development. So we'll first show in Fusion. We can open this add-in. And we get the dialog that has the ability to manage our scripts. In this case, there's a few scripts that exist. So we'll demo deleting one, and we'll go ahead and recreate it. And click Create Script. We'll give the name devcon demo2. And once that is created, I can go ahead and click the Edit Script button, which is going to open the script up in VS Code. So you can see here it's created this devcon demo2.ts file with a simple sample Hello Fusion application. It prompts us down the right corner to install the extension. So we'll go ahead and install that. And in the README for this extension, it points out that we need to enter some settings. These settings are for remote testing, so we will hold off on that for now. And we see the extension has also added these two buttons to run locally or run remotely. First, we're going to show running remote or running locally. So we will replace our basic Hello World application with one that's a little more useful. It's still a pretty simple application that just creates a new document. Then it creates a sketch on the document, adds a circle to the sketch, and then creates an extrusion to make a basic demo cylinder for us. And then it's going to save the file as devcon demo local. And when we run this locally, we're going to wind up seeing the output. We're going to see it show up in the canvas and in the data panel. So here we are running it, and we see everything show up as expected. So now we're going to show the same thing, but running remotely on the cloud. Before we do that, we'll make a couple of changes. We'll rename the file as devcon demo remote. Then we will make the extrusion a little bit longer so we see an actual difference. And we need to set up running remotely by entering our settings here. So we go into the extension settings and we'll enter our client ID and secret and personal access token. And the recording was paused as we did that. And once that's done, we will be ready to run remotely. And then we will see some different output, and we'll see the data panel will prompt us to refresh. So we're running that now, and we see that we're getting a token on the cloud, and we have a task that's executing. And we are seeing the output of the script coming back from the service. And once that's done here, we won't see it in the canvas, but we'll see that the data panel says that there's new data. So now we see that the task is finished. And if we go ahead and click refresh in the data panel, we will see the file that was created on the cloud. And if we open that, it will download it for us and show us in the canvas here. So you can see this will be a really useful tool to test things both locally and on the service without having to go to the trouble to submit jobs and things like that.
And now about deployment. So once you're ready to deploy your design automation application, then one of the first things you can do is go on the APS website, then check out design automation. And its documentation will continue a few tutorials or step-by-step guides. There's one for Fusion as well. And by default on the documentation site, you will find the curl requests, but there's a much more user-friendly version of it, which is the Postman walkthrough. So you can find the GitHub repo for that, along with the README, which will explain to you how you can use the existing Postman collections and environment variables and what you can do with it. These are the various tasks, like setting the nickname for your application or uploading your app bundle to the design automation server. The best thing is to go straight into Postman. You can just click the import button as you can see on the screen. Find the files which are available in the GitHub repo. So there's the Postman collection and also the Postman environment variables. These are the two files we need to import. As soon as you've done that, you can see on the left side, we now have the various requests or the collection of those under execute a Fusion script. But before you can use them, you have to make sure you're using the correct environment. So this is the DA4 Fusion that we also imported. So you have to go on it and make sure that you set the necessary variables, client ID, client secret nickname, and also the personal access token. And make sure you do not forget to click the save button once you modify the variables, otherwise these changes won't take effect. But as soon as you've done that, you can go back to the collections and you can test the various requests that we have here. You can see some of these variables are automatically populated from the environment variable collection. And we successfully got an access token. we could create the nickname for the application. And again, there are these various variables in curly braces, which are then populated from the environment variables. And we have also this other utility that we already mentioned, the DA-CLI tool, which now includes a configuration JSON file, which enables you to run exactly the same task as is done by the Postman collections. You just have to run npmi in order to install all the libraries that the sample needs. You can see the node modules are automatically populated. And here we will also work exactly with the same app bundle as the Postman tutorial. So we just need to download this configure design zip, unzip it, and then copy the folder directly into the root of this sample project. And as you can see, it contains the code that we will be running on the design automation server inside the app bundle. And just like in case of the other samples, we of course have to populate the variables like client ID, client secret, nickname, and also the personal access token that we want to use. And once you set those variables, again, it should provide the exact same functionality as in the Postman collection plus more. So these are the various tasks that are implemented here, including getting the list of engines, for example. So here they are, the various desktop products and their versions which are available. In case of Fusion, you have to go with the Fusion latest. That's the best. And now we can set up the app bundle. You can just click run. And as you can see, straight away we zipped up the app bundle, which we had locally with all the code, and then upload it to the design automation server. Now we are creating the activity as well, which, as I mentioned, is like a template for the work item that we will be running. And already we are ready to run the work item of that app bundle code. We should populate this folder inside your Fusion team project. As you can see, it's empty at the moment. I'm just refreshing to make sure it is indeed empty. Then we can go back to the application and then run the work item. So it's going to be fetching one of the Fusion team samples. It's called the nut. And it's going to be copying it over into the folder I previously pointed out. Plus, it's going to modify one of its parameters. It's going to make the nut a bit bigger and then also save that modified version in the same folder. And we're also printing some extra messages to the console, which will show up in the work item report. So now when we go back to Fusion team, the files should be now there. I just have to refresh the web page. And there it is. So that's the original model, the nut, and then we also have the modified one next to it. And just to point out another nice task option inside this sample, as you can see at the moment we are printing the message saving as a cool new document. Now I'm going to modify my app bundle code to say saving as a very cool new document. So this modification should of course show up in the work item report at the very end. So we have a new task as well called app bundle / work item, which is, as the name suggests, it's going to take the latest version of your app bundle code, zip it up, update it on the design automation server, straight away run a new work item, which is relying on this app bundle. So now when I'm checking the report, which is coming back, I should see this new message with the modified code. So here it is, saving as a very cool new document. And apart from tutorials, we also have now a configurator demo that you can have a look at. The source code is of course available for this as well, like for all the other samples. And in order to use it, just like in case of the other tutorials you've seen already many times probably, we need a personal access token. And the way you can do it is you can go to profile.autodesk.com, and there should be a section for personal access tokens. You can just generate a new one. Make sure you select the product scope, which is design automation for Fusion. It's going to provide you with a personal access token you can use. I'm placing it inside the edit box straight away, and then I can log in with my Autodesk account. And as soon as that is done, on the left side, I should see all the hubs and projects that I have access to, including all the models I have. And now when I'm selecting a Fusion model, then it should be loaded into the viewer. This is actually one of the modified models I have here. I just have to select one of the versions. And I thought it could be fun to point out this error because it's just showing again that you definitely need a personal access token in order to take advantage of this. And when I logged in, that edit box got emptied for some reason, so I've just had to paste it back in. But now this time when I'm selecting the model again, design automation can be used to extract all the parameters from the model. And I should be able to modify it here as well, but I'm not just switching over to the actual original model that I had. It's a very simple box model, as you can see. So we are just getting all the user parameters available inside the model and listing them here, and I can just go into any of them and modify them as I wish. So I'm just going to change thickness and depth and then click Update Design. And it's going to be, of course, opening up the given model from the my Fusion team account, then modify the parameter, save the changes, updating the model itself. But then it also needs to generate something called the SVF, which is used by our web-based viewer that is used in this sample as well. So once that SVF format is generated, then I will be able to load it on the web page. So that's what we have to wait for here for a couple of seconds. And as soon as the modified model's SVF format is available, as you can see here, I loaded it into the viewer straight away.
Okay, that concludes our discussion of design automation for Fusion. Thank you.
Thank you.